Assalamu alaikum, respected students. Today we discuss new problems related to the thermodynamics. When boiling a pot of water, some of the energy is used to increase the temperature of the water, while some of the energy is required to convert liquid water into the water vapors. From the total energy required to convert 100 ml of liquid water at 25 Celsius to water vapors at 100 Celsius, calculate what percent is used to increase the temperature of the water. Specific heat capacity of water is 4.184 joule per gram per Kelvin per gram Kelvin. Change in enthalpy of the water when change water from liquid into the vapor phase or gaseous phase is 2257 joule per gram. It is the first part of this numerical. Second part of this numerical, calculate the standard Gibbs free energy change for the following reactions using provided information. What is the information provided? Liquid water, when treated with the oxygen, hydrogen peroxide is formed. The standard free energy change for the hydrogen peroxide is minus 20.4 kilojoule per mole, and Gibbs free energy change for the water minus 273.2 kilojoule per mole. Okay, first we focus in first part. The first part, there are the two things. First of all, we have to calculate the heat which was used to increase the temperature of water from 25 Celsius to 100 Celsius. Keep in mind, divide your numerical in two parts. First of all, you have to calculate the heat which was used to increase the temperature from 25 Celsius to 100 Celsius. Other part of this numerical, calculation of the heat which was used to change that water at 100 Celsius into vapor state. Okay, first, to increase the temperature from 25 to 100 Celsius. Second, at that 100 Celsius temperature, water molecules change from liquid to vapor state. Okay, first we calculate. For the calculation, we put the data. What is the data? Volume of water is given 100 ml. Then what would be the mass of that 100 ml of water? We know that density of water is 1 gram per ml. So 100 ml of water will be equal to 100 gram. Next, what is the initial temperature? 25 Celsius. What is the final temperature? 100 Celsius. What is the change in temperature? 75 Celsius. 100 minus 25. Specific heat capacity of water is given 4.184 joule per gram Kelvin. And heat of vaporization, in other words, enthalpy of vaporization, also given in the data, that is the 2257 joule per gram. First, we calculate the energy or heat of water from 25 Celsius to 100 Celsius. What is the formula? Formula is very easy. Heat is equal to mass multiplied by the specific heat of water, heat capacity of water, and change in temperature. Okay, what is the mass of water? 100 gram. What is the heat capacity of water? 4.184 joule per gram Kelvin, and change in temperature is 25. Okay, 25 is equal to 31,380 joule. Answer is that 31,380 joule. That is the answer in joule. Next, first part, we have calculated the heat which was used to change the temperature of water from 25 to 100 Celsius. Next, to calculate the energy to vaporize the water from 100 Celsius. What will be the formula? Mass multiplied by change in enthalpy of vaporization. Mass is the 100 gram, and enthalpy of vaporization or heat of vaporization is same, is 2257 joule per gram. The answer will be 2,25,700 joule. Total energy of first step and second step by the addition of energy of first step 31,380 joule plus second step energy to vaporize the water 2,25,700 joule will be equal to the 2,57,080 joule. Now, well, what is the demand of the numerical? The demand of the numerical, calculate the percentage of the heat okay. How we can calculate? Percentage for heating is equal to heat required to change the temperature from 25 Celsius to 100 Celsius divided by total energy or total heat multiplied with the 100. The percentage used to heat the water is equal to 12.2%. That's the first part of that numerical. Second part of this numerical, calculate the Gibbs free energy, change in Gibbs free energy of the total reaction. Very simple formula, a summation of the change in Gibbs free energy of all the product minus summation of change in Gibbs free energy of all the reactants. We know that there are the two reactants in the reaction and one is product. Product is hydrogen peroxide and reactant is water. Other one is oxygen. Gibbs free energy of water is also given in the data, and Gibbs free energy of hydrogen peroxide also given in the data, but oxygen is not given because that's the elemental form, and elemental form Gibbs free energy is 0 kilojoule per mole. Okay, next apply this formula and put the values of the Gibbs free energies in the formula. First of all, minus 120.4 kilojoule per mole, that is the hydrogen peroxide, minus Gibbs free energy of the reactants, that's the water, plus that's the oxygen. The answer will be 116.8 kilojoule per mole. The change in free energy of the reaction is 116.8 kilojoule per mole. That's the answer. Hope so you got all the points related to this numerical, very easy numerical. And in next video we will discuss new topics related to the thermodynamics. Take care. Allah Hafiz.